And the last talk will be by Diego Rodriguez, who is a software developer at CERN and my former colleague at CERN. And he works mainly on RIANA, or the project called Reproducible Analysis platform, but also on CERN Open Data Portal, where I was before, and Invenio, a digital repository framework. So Diego, are you here with us? And thank you so much for joining. It is really great to see you here. And the floor is yours.
Thank you very much. Nice to see you too. Okay, so good afternoon, everyone, and good evening for the ones that are in the same time zone as me. Today I will be talking to you about our efforts in my team at CERN running reproducible, open and reproducible research services. So just a quick reminder to know where we stand. For us at CERN, the scope for open and reproducible research is it's very clear. Building the LHC was a milestone for humankind, and it wasn't an easy task. So we are sure that the produced data at CERN it has a great value, and this is a fact. And we can look at all experiments like SHIELD that stopped the data taking in 2007. And even 10 years after, analysis will run with this data. Also, it's very important the knowledge retained by people. And at CERN, we have a big challenge with the high turnover. And if you see this screenshot that I'm sharing here, it just represents that from 2000, from the first paper from LHC collaboration, half of the authors are there, but the rest are gone. So this is a real challenge we have. And if to all of this we add the complexity of running analysis for LHC data, we get a nice recipe. We can get a glimpse of the complexity of those analyses here. From data taking from the final to the final results, there are many steps in the middle and many nuances. And you can note how the order of magnitude from petabytes per second to when the data gets filtered, and the analysis can take from weeks to days and to hours. And this is performed from different people, by different people and different teams sometimes, which makes it also more interesting. So going into the services. CERN, in view of this important reality, published the CERN Open Data Portal in 2014. So it's a digital repository that disseminates over 2.4 petabytes of physics data. And we have a lot of records and a lot of files that are offered through the portal. And the main task of this repository is to make it easy for people to use this data. And we do our best for that. We have a faceted search. We enable large file downloads of the order of gigabytes. And we provide data provenance, so which is also important. So I will just go through some use cases. So the first of them of the CERN Open Data Portal is education. From high school to university students have been using the CERN Open Data to analyze the LHC data, to have a look and learn. And they have been using tools that are offered in the portal, such as embedded physics event visualizers and histogram viewers. But besides the education use case, something that has gained popularity lately is the usage in research and independent research, not inside CERN. For a long time, this was believed to not be possible, but since 2017, there have been a few publications that actually materialized this use case with success. They were able to use it being completely outside of the CERN collaborations. So to wrap up for the open data service, what we have on it is like a bunch of records and data, and some of them are analysis examples. So people can actually browse the portal, find analysis, and download virtual machines, pull data from the portal, and then run the code that it's provided according to the instructions and get results. But still, this is not very straightforward. So we've kind of answered 3 questions out of the 4 that we would be happy with to make it easy for people. Because we answered the question, what is the data? We answered the question, what is the code? And we answered the question, what is the environment? But we didn't quite tackle what the workflow is, which we have been talking today. And this ranges from having bash scripts. We talked now like having a script that wraps everything and writing a README. It varies, and it's a complex topic. And because we didn't tackle it and we didn't have any tool to tackle, we created a new service, a new project, and we are running it as a service called Rihanna, which aims at filling this gap. So far we offer data, yeah, but we have to make it useful. And in 2017, we created this project, and which is an open source project, and it has the LHC analysis in mind, but we are trying to make it extensible so we can cover other use cases through collaborations. So in a nutshell, if I had to say it very quickly, Rihanna, it's a platform that focuses on the declarative programming approach. So users provide in a high-level language. You can see here in this YAML file, and they provide what they want, what they have, and what they want the system to do. For instance, in this example, we provide the user provides some code, some parameters, and then it says my workflow is these 2 steps: run root command a couple of times with these parameters, and they go in this order, and then I will get this result. But the user doesn't have to care in which HPC facilities this is going to run, if it's going to meet the requirements. It's the platform that will find the environment and put everything together. Of course, this is a very simple example. The real cases are not as simple as this one. So I just picked one that can illustrate our for our example here. So how does this look? So this looks like this. Users would come to the platform. Here you see it says sign in with single sign-on, because at CERN we have a central single sign-on instance, but you could run this Rihanna with local users with user and password as well. And once you log into it, you will get your credentials on how to interact with the platform. And I will make it a bit interactive now, so to show you how it would actually look. So I hope you can see my chains here. So I'm gonna looking into an instance of Rihanna that I have running locally. Physicists would come and to see this in the first place, that is their list of workflows. But what we left it in the presentation was you see some credentials which you use to configure your terminal, your terminal emulator. And then here, which I configured already beforehand, you would be able to see if you are connected to this instance. Right now I'm running locally to foresee problems with the network, to not have a catastrophe. And basically they are offered with this Rihanna client command line interface, which has a lot of features. I will just name them quickly, so maybe someone is interested lately when we can have a conversation about it. So basically, users will have commands to manage their workflows, create, delete, diff, list, to execute their workflows, run, restart, you name it. Then there are commands to open interactive sessions, which we will see in the user interface later, which is more evident, and then to manage files inside the workflows. Then there are other administrative commands, such as checking how the quota is going, which you saw in the previous screenshot, and secret management. And secret management is important at CERN because sometimes physicists need to add private resources to access private resources in their analysis. So they can add tokens, so they can retrieve the data and finish their workflow. Okay, so what we are gonna do now, it's a quick edition of what we showed before. This is the same YAML that we saw in the presentation. I'm gonna just change the number of events of this. And we are gonna do a Rihanna client run, and we are gonna call it Roofit demo. And as we go through the UI, this will be executed. You see that it's coming in the user interface, but we will go through one that was already run before. For instance, this Roofit Javits. So what are these items here? Is when you run a workflow, this is actually a workflow run. And then when the physicist gets in, they can basically see the logs of each of these steps. So if you remember in this file, we have two steps: gen data and fit data. So the physicist would come here and look for the step that they want to check the logs for. And also we offer some metadata here: which command was run, in which environment, Docker image, which compute backend. In this case, it was Kubernetes. It could be HP Condor, Slurm. And then also the physicist can come and go to the workspace of the workflow and see which files were generated. For instance, because this workflow was run already, we could see the animation of how the workflow was executed. So this is, again, a really toy example. In real life, this looks more like a monster rather than a puppy, I would say. And then there is a last tab where you can see what you submitted. It's basically a JSON representation of what you created. Good. So if we go back, we should be able to see that our Roofit demo was successfully executed. It was now, it's like 7:37 here in Geneva. And the last thing that I would like to mention from this list is, of course, you can search, you can filter by status, for instance, search for the one that were failed, and sort. But there is one last thing that I mentioned before, that you can open interactive sessions to inside your workflows. So say that something went wrong, for instance, in this workflow. So we would be able to open an interactive session, which is basically opening a Jupyter notebook inside the cluster. And when you click it, you come into a Jupyter notebook interface that most of you probably are used. And here we see that there is the code, but actually no results were produced. So perhaps the physicist can have a look here. Also, you can open a terminal, and you would go into the space, but here you can see the same. You can see that there is the code that we just submitted, but nothing was run. Perhaps as a physicist, you would have your command line tools to inspect what went wrong. Of course, now we are not doing anything real, so we can shut down this terminal, close this. And then if we come back to the user interface, this interactive session keeps open, but because we don't need it, we will just close it. Okay. And the last thing that I didn't show is, like, when you run analysis, of course, you produce something nice, some plot. So of course you have some capabilities to preview the files as well as download them. And then one last thing to stress a point of how we see this and how we see the reproducible analysis at CERN is that we are trying to offer this tool to physicists to be able to wiggle. That was a very nice term from Bertram's keynote, because if we see what the difference is for a physicist to say, I'm gonna run my my previous analysis. I want to run it in HT Condor. For a physicist, it would be only to change a line in their specification and say, I want the compute backend for this step to be HT Condor. So wiggling as a concept is something that we are trying to do, and it's fun to see it in someone else's words. So coming back to the presentation, I hope I'm not going over time. Let's go full screen. Let's use this. All right. So we left it here. So I left some screenshots of how it will look like for someone that will see the presentation afterwards, but you have seen all of this. So these are all the views that you can see on the Rihanna platform. So I will go now briefly to talk about what are the technologies behind these services that I've been mentioning. So for the repository, for the CERN Open Data Portal, the technology behind is the Invenio digital repository, which is behind services you might or might not know, such as HEP Data, Inspire HEP, and perhaps another you might all of you know. So they are using the same technology, which is based on Python, Flask, React, using Elasticsearch for powerful search, PostgreSQL for robust database. And then on the side of Rihanna, this was something that we created in 2017, as I said, from scratch, but we didn't want to build something completely new. We just wanted to put together the pieces that already existed at CERN and wrap it in a cloud native application and make it extensible. So what does this mean? It means that we aimed at having different storage backends like EOS. It's something that is specific to CERN, but also we have CFFS, which is something that people in the Kubernetes world uses, and it's open source. Also from compute backends, not everyone might have HT Condor, not everyone might have Slurm, but we try to adapt. And for the workflows, it's the same. We had synergies with life sciences by extending Rihanna and making it possible to run CWL workflows. And then lastly, the environments. We're talking about Docker, Singularity, and the CERN VM file system. And we wrap everything up, and we try to offer a comprehensive user interface with the CLI that I show you, with the user interface, with an interactive Jupyter notebook to be able to explore. And making this extensible allowed us to have even synergies outside high energy physics, like astronomy with the Geneva Observatory, or even having deployments in the US. The Notre Dame University and New York University are two universities that we are collaborating with, and they have Rihanna instances running. And this means that Rihanna was run in big computer centers of the US, like NERSC or Blue Waters. So to wrap it up, I would say you can go and try them out if you have any interest. For open data, it's very easy. You just can go there and find if there is something of interest for you. It's very nice and very nicely documented, and everything is available for you to try out there. You can see events of the LHC represented in your web browser, which is pretty impressive. And for Rihanna, you can install it locally. For instance, the demo that I did in this presentation was running locally, just in case there was some problem with the network. But as you see, it runs, and you can install it on your on premises, on your computer center. It's as easy as using Helm install. And this has been used, as I mentioned before, in the US, NERSC, Blue Waters, and New York University. We see there, probably you don't notice, but it's Rihanna at NYU. So it's nice to see it deployed in other places. And before saying goodbye, what comes next in Rihanna is like, we have something that is lacking for user experience, which is when users look for logs, as you saw in the user interface, you saw everything populated already. But if you run a 5 hours job, until the 5 hours job finishes, there are no logs. So this is kind of a problem for someone that is running long-lasting jobs, which is most of our users. So we will be implementing a live logs feature, which will be streaming each line of the logs to the user, so they can get early feedback and see maybe something is going wrong already. And I can highlight this from the near future, and in farther future, we'll be working around summer on making an abstraction layer for Rihanna to be able to use interfaces as Amazon S3, which is kind of very scalable and something that would help a lot with our different synergies with other projects. That's it from the roadmap. If you want to know more about the project, keep an eye on our website, on our Twitter, and you will see how things go on. Perhaps something is not in, maybe you want to see something in the future, just have a look to our channels. If you have any doubt, drop a message in the chat. We'll be super happy to talk to you, or you can talk to me directly today. Everything we do is open source, so we are super happy to collaborate. Just, we are here, and feel free.
Thank you so much. Thank you for the great talk. Okay, let's let's wait a minute if there are any questions. But yeah, I see that there's just like, there was so much progress on Rihanna. And I mean, this like whole new interface is really interesting. But I think that one thing that you didn't mention is that, so maybe like the first question is like, who are the primary users of Rihanna? So for example, CERN Open Data, obviously it is like the public, right? So anyone can go there. Who are kind of like the primary users or the intended users of Rihanna? Is it like,
so,
yeah.
Yeah, so are the people that are running actually the analysis at CERN, like on the different levels that I showed before. We are working, I use this slide on the beginning, slide number 4. So we are working with people that are doing analysis in this second half of this diagram. Not the RECO steps when the things are very big. We are working on reprocessing and statistical analysis.
Okay, but then I mean, it is still not open for the public, right? It is still, it's going to be kind of like for each different right, like working group at CERN in an experiment, they're only going to be able to access this. It's like not kind of like beyond their own experiment, right? And maybe my next question is like, if that's the case, or if that's the case, that the Rihanna is only available for people within one collaboration, then potentially this kind of like review process that maybe Mandy talked about, you know, how like different physics analysis go through different steps of approvals, then this process can maybe be automatized with Rihanna, and then kind of like people who review analysis before it was like sent for publication can do that. Does that make sense?
Yeah, it does. It does. So I came back to this slide. So the first answer to the first question, there is a central service now. So you cannot go outside CERN, but people inside the CERN intranet can go to rihanna.cern.ch. So there is this central service notion right now, and we have people from different collaborations working on the same platform, but everything is protected, right? So you cannot see others people work. And regarding the second question on the approval, that's why I came to this slide. We will be working on user groups and authorizations in the future, because right now it's only just single user. You go there and you have your private stuff, but at some point we will share. And then when we have groups, we will be able to have a group for the specific collaboration. And then the people inside this collaboration, the convener, will be able to see all the analysis for this specific group, and then be able to validate, if that answers the question.
Okay, great. Yeah, that's very exciting.